The following is an example of finding the area between curves. We're asked to find the region bounded by the curve y equals x squared, y equals 0 between -1 and 2. So if we put in our limits here, so from -1, that's here, up to 2, so that would be there. What we're asked to find is the region in here and in here, from -1 to 2. Well, in order to do that, we needed a sketch. We need to know points of intersection. So since we're only talking about one curve here, we don't need to worry about that. We just need to know this is -1, this is this is +2, so we're given that. So now we need a rectangle. The representative rectangle that's gives us the representation of the area we're trying to find. So if we put in a rectangle here, we always have two options, dx and dy. This, of course, is a dx rectangle. Now, what we want is to make sure that the top of the rectangle and the bottom of the rectangle remain on the same curves. So if we actually move this rectangle across our region, the top would be on the curve y equals x squared and the bottom on y equals 0. And as we move it, that stays consistent through this section. Here it would disappear altogether, so it would be 0, so that's okay. And over here, the top is still x squared and the bottom is still y equals 0. So this rectangle will work, and let us find the area by using one integral. So setting up the integral then, this is a dx rectangle, and we need to take the integral, so the area is equal to the integral from -1, which is here, up to 2, always across the bottom or the small end of our representative rectangle. Or, because this is dx, we need x values. So the x value here is -1, up to 2. The width of the rectangle is dx. Now we need the height of the rectangle. So the height of the rectangle is always the top curve minus the bottom. And that's why we want it to stay the same the whole way through, so that we always have the same top curve and the same bottom curve. So the top curve here is this one, which is y equals x squared. We have dx, so we need x's, so x squared is good. The bottom curve is this, which is the x-axis, or y equals 0, so minus 0. And that is the integral that represents the area that we are trying to find in here. So solving then gives us x to the 3 over 3 evaluated from -1 to 2, which gives us 2 cubed over 3 minus -1 cubed over 3, which gives us 8 over 3 minus is plus 1 over 3, so 8 over 3 plus 1 over 3 is 9 over 3, or 3 square units, or units squared.